Thank you for your approval. I appreciate it. So we're going to learn about a few different kinds of special segments. And the first one is some segments that intersect. These are chords. And so because mathematicians are so good and creative at naming things, this is called the intersecting chords theorem. And the intersecting chords theorem goes like this. Here's what the theorem looks like. It says, if I take segment HK right here, and I multiply it by the rest of the chord, which is segment KG, that the product of the length of those two segments is equal to the product of the other two segments. So JK multiplied by KI. That's what the intersecting chords theorem says. If you take the product of the two segments of one chord and you multiply by the product of the segments of the other chord, those products should be equivalent. And so let me give you an example with some actual numbers. Because even though you've reached the part of math where we're mostly all about letters, never hurt to have some numbers every now and then.
It is really weird. Is that a 4 or those two parallel marks?
Neither.
No, they're not diddly doodles.
So we can use the intersecting chords theorem to find the missing piece of chord BD. Specifically, we're looking for segment BE. That's the part we don't know. Okay. So we'll take the half of the first chord, which is 5, and multiply by half of the second chord, which is 6. And that should be equivalent to half of the other chord, 4, multiplied by the other piece. I'm saying half, I don't mean half, because it's not cut in half. You get the idea. The other segment. So, yes?
So 30 equals 4x, right?
Yes, that's true. 5 times 6 is 30. When you went, ooh, ooh, and raised your hand, I thought you were going to tell me the final answer. I didn't know you were just going to tell me what 5 times 6 is. So keep it going. Uh-huh. Ooh, ooh, I know multiplication. As long as 7's not the end of your sentence, then yes. 7.
What? I'm thinking 7.2.
Why are you thinking that?
I don't know.
Where's your calculator? Wait, you have a calculator in your hand and you're still guessing?
7.5.
7.5.
Okay, I had a calculator, but I was trying to do it in my head.
You know what? You're trying to,
Before it.
as the kids say, you're trying to flex a little too hard. I got a calculator, but I'm just going to use this to gesture while I do mental math.
No, she was doing it because of math team.
Oh, practicing for math
We're
team.
trying to get better at fast math, and we just started yesterday, so.
Okay, let's make our other two segments here. And this time we're going to try one that's a little different because I'm going to give you 2 measurements and that's it. Really? No fooling. As my daughter would say, are you kidding me? She says, are you kidding me all the time? Usually because I'm kidding her, but sometimes just because she doesn't like what I said. Turn off the TV, it's time to take a bath. Are you kidding me? Although yesterday I made her a grilled cheese sandwich for dinner. She was eating it and she said, I love grilled cheese. And I said, is grilled cheese your favorite food? And she said, yeah. And I said, what do you love more, your mommy or grilled cheese? And she said, mommy. I said, what do you love more, your grandma or grilled cheese? She said, grandma. What do you love more, daddy or grilled cheese?
Grilled cheese.
Grilled cheese. I know. I know. Mhm. I mean, it was a pretty good grilled cheese sandwich. That was some of my best work.
What's your worst work? Just slap
One time I tried to make her a fancy grilled cheese sandwich where I used 2 different kinds of cheese, which was fine, except one of the kinds of cheese was white. And if it doesn't have yellow cheese, she doesn't think it's a real grilled cheese sandwich. All right. So let's set up our equation here. We got NK times KL. So that's going to be 15 times X is equivalent to these 2 segments, X plus 1 times 10. Now you can put them in any order, but I'm going to put the 10 first so that it looks a little more like the distributive property, since that's what we're going to have to do here. You could do X plus 1 and then the 10. It would just look kind of weird. There you go, Emily. It would be weird, but correct if you put the 10 second. Oh, I know the left side. 15 times X is 15X. Now that I've done the hard part for you, what's, yes, distributive property says 10X plus 10. Outstanding. And then, that's a great idea.
Divide by 5 on both sides? What?
Oh, are you cool with what I just wrote?
Divide by 10x.
You said subtract 10. Oh, 10X. Oh, well, that makes a big difference. You said subtract 10, so I did.
I'm not good at math.
That's not math, it's just reading.
I'm also really bad at reading. I'm not very good at math and I'm terrible at reading.
Equals 2.
It's not math to see that there's an X attached to it. That's just a letter. Thank you, English. The one thing you've contributed to society, the letters that we use in math and science.
We're still doing
Yeah, really.
An essay is just like a really complicated math problem. At the end, I'll give you values for all the letters A through Z, and you can solve your essay.
Wait, can you actually do that?
One person is excited about solving an essay. I'll give you the values of all of the letters except for like M, and then you can solve for M.
Oh gosh.
No, I just want you to tell me all the letters and then.
If you want a 100, you got to solve for M. Your essay equals 100. What's the value of M?
Dude, that sounds great.
That way, people who are bad at English could still get a good grade if you're good at math.
I'm bad at English.
So-
I like that.
I got X equals 2. Am I done? Number 1, no, I'm not done because that's the incorrect word. It should be, am I finished?
You are not finished.
And I'm not finished either because the question did not say find X,
You have to substitute 2.
Find OM.
find OM. So I need to find OK, and I need to find KM, and then I will add those 2 segments together to get the total. So, OK, say that again. So OK is X plus 1, so 2 plus 1. Do you know what 2 plus 1 is? 5 is so close. Good try. 3, so OK is going to be 3. And KM, no calculator required because the problem just tells me KM is 10. It is 13. Good job. Oh, if I ever need somebody to add 2 whole numbers together, I know exactly who I'm coming to.
Calculator.
The calculator. It seems easier than it should be.
I agree. Like,
I don't even have to do this
Oh my god.
bless you.
You don't get to. You don't get to do
on.
this.
I don't get
Well,
You sound disappointed, huh?
let me give you a new one. The secants and segments theorem.
That doesn't sound nice.
That sounds like an unpleasant.
Really? An unpleasant meal?
Yeah, secants and segments sounds like you cut up like a gross animal.
You cut up a gross. Okay. Okay, continue.
And then you took all the worst parts of it
Mm-hmm.
and put that on a plate. And it's like, here you
And
go.
sprinkled some
Something
seasoning
with-
over it
No,
to
like,
make it look like you
rabbit
actually
swirl.
cooked it.
Mm-hmm. Mm-hmm.
And
I'd
then,
rather eat a rabbit swirl.
and then basically like, here's your supper. Ew, get that roadkill.
it's like secants.
Would you
tell
would you say
every
that
joke
Peyton, if your
again
mom made it?
as she was saying it? It's like secants sound like muscle that's like half deteriorated, like really tough muscle, and then segments just sounds like blood vessels. So that's what I can see where she's getting a gross meal from.
Wow.
In fact,
So these are not chords. These are secants. What's the difference again? Remind me.
secants go off.
Yeah, secants leave the circle. Secants go off, as the kids say.
Oh my god.
So the formula here is a little bit different. We're still going to take two pieces of each secant and multiply them together, but the pieces are a little unusual. So for our first secant, we're going to use a UV as our example. We're going to take all of UV, the entire secant UV, and we're going to multiply it by the outside piece.
Oh. Huh.
So this will be, oops, this will be all of UV, the entire segment, multiplied by the exterior piece, which is XU. And that will equal the exact same thing for the other segment. The entire segment, so WU multiplied by the outside piece.
Why you?
I ask myself the same question every day. Why, God? Why me? But he never answers. And I know why. I did this to myself.
You why? Why would it be why you? Can it be or does it have
So
to
why
be?
is it you? Why?
Yeah.
You
Why
put-
can't-
why do you
you
want
put
why
X
you?
for the last one. I thought they had to correlate.
Because X.
Hey, you told us that the segments have to line up so we can find them properly.
I told you that when you're naming a triangle or quadrilateral.
Well, it's still a good practice.
All right, thank you.
Those were.
Why me? Why?
You signed up for it. You went to college for it.
You went to college to invest in this.
No, joke's on you. I didn't go to college.
You went
That's
to
right. You went to the
school.
pizza box and walked in the home.
Imagine going back in time and telling yourself this is what you'll be doing.
Yeah, and then computer science and his computer
Being
science
bullied
job.
by high schoolers for the rest of your life.
Do you think he would say?
The advice I would give myself if I could go back and see what my career was going to look like would be you should pay way more attention in science classes and save your notes because someday you're going to need those. Like, no, I'm never going to be a science teacher. Yeah, you are. You don't know it now, but it's coming.
It may be a while down the line in your
Mhm.
teaching career, but it's gonna happen.
Like 2 years ago, if somebody had said, hey, next year you're teaching science, I'm like, that's ridiculous.
And then they say in English and social studies. and
I'm
then-
completely unqualified for all that stuff. That's true, you are, but
But we'll pay you more.
pay me more.
Yeah, didn't you say that you know science and math?
That's if
you
he's
can pay
If you're certified in science and math. That's what I meant by unqualified. I'm not certified. I can't believe they hired me at all because the restraining order says I'm not supposed to be within 500 feet of a school. So anyway, let's go ahead and apply our secants and segments theorem. You light a bus on fire one time. So, how was I supposed to know that you couldn't take a grill into a bus? It's not like it's written anywhere. Anyway, so we're going to start with segment IJ. So we take the full segment IJ, which is how long? 22. So it'll be the full segment, 18 plus 4. You can just write 22 if you want, but I'm writing 18 plus 4 so you can see where we got it. And I'm going to multiply it by the outside piece, which is 4. Exactly right. If I have set this up correctly, it should be equal in measurement to the other complete secant, kj, which is, that's if I was multiplying. Again, that's if I was multiplying.
What?
Someone else say 6x.
6x?
Correct. No.
6 plus X.
Thank you. 6 plus x. See, if I want to know how long the segment is, I add the two pieces together. I don't multiply them. And that is going to be multiplied by
6.
the outside piece, which is 6.
I made that same mistake. I wrote 6 on my paper.
6x, or as that one rapper would pronounce it, Bex. So 18 plus 4 times 4 is going to be, thank you, 88. Very good. I'm going to have to do a little bit of distributive property over here.
6x plus 36.
Very good. Thank you. 6x plus 36. Outstanding job.
And you subtract 36.
Yep. That is an excellent idea. I support it. So that's going to give me 52 equals 6x.
X equals 8.66666666667.
So I think I'm just going to write that as a reduced fraction then, which would be 52 sixths reduces to 28 thirds, right? 26 thirds. I can't divide. 26 thirds. Good job, everybody.
Okay, so we tried very hard.
Now there is one more example we haven't looked at.
Oh,
Tangent.
We haven't talked about tangents.
what about sin? No.
I saw the
and
sign.
cosine.
What about them?
Are we gonna learn those with triangles, or are we just gonna learn tangents?
You already learned those with triangles, I hope.
Not triangles.
I taught them to you.
circles. Not circles.
Are we going to apply sine, cosine to circles? The answer is yes, eventually. But right now we're just focusing on segments, secants, tangents, and chords. Sine and cosine, I'm sorry to say, are not also the name of segments in circles. Tangent is the only crossover. And we talked about it yesterday and the day before that it's still means the same thing. It's still a ratio. But it's also can be drawn as a segment where one side of the triangle is the tangent line and the other side is the radius. So this is yesterday.
Oh, today's Tuesday.
Sure is. So this one, the secant still looks the same. It's the entire secant, segment BZ, multiplied by the little piece, the outside piece, which is CZ. I shouldn't call it the little piece because it's not always the small one, but it is always the outside one. Equals, now there is no inside piece and outside piece for a tangent. The whole thing's outside. So the other side of this one is just that piece times itself. So you can do AZ times AZ, or you can do AZ squared. Oh, I forgot to name this one. This one, if you had to guess, is called the, let's see, the one with this, the two with this, the one with two secants was the secants and segments theorem.
The tangents and segments.
but there's also a secant. So this is the secant and tangent. That's dumb.
We need to come up with better names.
You should name them.
Cool.
All right, this one's going to be named George.
Wait, what are the others going to be named? Linda?
Luann and Betsy.
I like those. Now we don't have one of these formulas for two tangents. Any guesses why?
Because they don't do the things.
They don't do the thing. I'm going to need you to be a little less specific because I'm worried that if you say they don't do the thing, that's just going to give it all away.
They don't do math. No.
They don't, oh my gosh. Because there are not two segments to each of them.
That's correct. So could I say GH squared equals JH squared? I could. That seems awfully labor intensive though. Isn't GH squared?
It's just they equal each other.
They equal each other. There we go. So I could do GH squared equals JH squared, but that's unnecessarily complicated. Really, it's just that they're equal to each other. You can write that they're squared if you're like, I want to do this in a more difficult way. You could do square root of GH equals square root of JH if you want to. You can do cube root of JH to the 1/4 power equals cube root of GH to the 1/4 power if you're a maniac. But the easiest thing to do is just to say that they are equal to each other. This is true if they come from a common point. These both come from point H. If they were two tangent lines coming from different points, of course, all bets are off. But if they come from the same common point,
Then all bets are
What's this one's name?
I wrote it, the two tangent theorem.
Linda.
Oh, it's a Christian name is gonna be Lola.
Yes.
Jesus. Didn't we say Jesus is like one of the most common names? That's interesting. Jesus and Mohammed,
And
Both-
Muhammad and Muhammad.
both extremely common names. People like to name their children after deities, I suppose. And yet, not one kid that I know of named Buddha.
Who?
Buddha. I guess
Never
Buddha is
know.
not technically a deity. Maybe that's why.
Well, it's not a very common religion. Yeah, in this area, you don't see many Buddhists.
It's more down there.
I've only ever taught one Abraham.
Down there,
Yeah.
you only taught one what?
Abraham.
Was he named after Abraham, like the
Lincoln?
Abraham, or like Abraham Lincoln?
I
Because either one is kind of interesting.
don't know. He was a Christian who was also African American, so I assume he had strong ties to both biblical Abraham and Abraham Lincoln. Maybe it's just an interesting coincidence that he could get one name that had both of them in there. I like that.
feel like naming a kid
I liked
after
Abraham.
something-
He was a good seed.
He's a good what?
He was a good seed.
Naming a kid after something seems not like the best idea to me. Just because then they're named after something and they don't have like their own name.
Well, what's even worse is if you name your kid something and then later their name becomes popular for a reason you do not appreciate.
All those poor Adolfs.
No matter what name you have, you can always find someone awful who has the same name. Okay, so here's a use for the two tangent theorem. This is what's called an inscribed triangle, inscribed around the circle so that the edges of the circle touch all of the sides of the triangle. No, I'm sorry, I got that backwards. It's a circumscribed triangle, an inscribed circle. Inscribed is in the shape. The tangent theorem will help us figure out how long these segments are, because segment AD would be congruent in length to segment AF. Segment FC would be congruent in length to segment CE. And DB would be congruent in length to BE. So in this way, if I gave you just a few measurements, like if I said, well, this is going to be 2, and this whole thing is going to be 3, and this is going to be, let's say, 3. You could then figure out all the rest of the measurements. If segment AF is 3, then segment AD would also have to be 3. If DB is 2, that means EB would also be 2. And since we were told the entire segment BC was 3, that means CE would have to be 1, which means FC is. And so now I have a 3, 4, 5 triangle, which tells me that angle C is a right angle. And I could use inverse trig functions to figure out the other 2 angles if I wanted to. I do not. I mean, I do eventually, but I don't right now. So this will be a right angle. And if I wanted to know, I'm not going to do this, but if I wanted to know angle A, I could use inverse tangent, for example, of 3/4. Because this side is 3 and this side's 4. So the measure of angle A would be inverse tangent of 3/4. And then once I knew angle A, finding angle B would be really easy. I'd do 90 minus the measure of angle A. Yo.
For BC, did you just add them together? Is that how you got 3? Did you just like do?
I told 3, the part in blue was given. You were given the entire thing was 3. If DB was 2, that means EB also has to be 2 because they're congruent. You with me there?
Yeah.
So if the whole thing's 3 and BE is 2, then CE would have to be 1 so that the total is 3. And once we knew CE, we could find CF because those are congruent. And you've got some sweet trig skills that could be used to figure out all of the angles if we knew it was a right triangle. And how did we know this one was a right triangle?
3, 4, 5.
3, 4, 5 is the Pythagorean triple. That's why my SoundCloud is white chocolate 3, 4, 5.
Oh, that's.
For a while, we all just thought that you pick random numbers to say.
It's Pythagorean triple. And white chocolate 5, 12, 13 was already taken.
Not as
Go to his original account, but he got nobody else would want that game.
Does anybody have any questions about special segments or about spitting straight bars on your SoundCloud?
How many followers do you have on SoundCloud?
What?
How many followers do you have on SoundCloud?
More than 2. And that's all I'll say. And only one of those is my alt account. Any questions from anybody about anything?
No.
That was fun.
That's not a question.